So let's look at number 19. We have a exponential equation, and one of the ways that we talked about for solving an exponential equation is to take the log, and then we will be able to use our power property of logs in order to move the exponent as a multiplication to the log. And so what we had done in class was take the natural log of both sides. So let's go ahead and do that. I'm going to do the natural log on 9 to the v minus 6, and that's going to be equal to the natural log of 12. So I'm doing the same thing to both sides, and then I'm going to use my power property. That's going to allow me to rewrite the exponent as multiplication times the log. So I have v minus 6 times natural log of 9 equals natural log of 12. And then, since we actually have multiplication here, I'm going to undo multiplying by the natural log of 9 by dividing by the natural log of 9. Okay, so that's going to cancel, and I get v minus 6 equals ln of 12 over ln of 9, and then our last step is just to add 6 to both sides. So what we end up getting here is v equals 7.1309. So of course I want to plug in that value just to double check it, and I actually already did that in my calculator. When I plug in this decimal, I get 11.9992, and of course it's not actually 12 because we have already truncated that number when we rounded it to the nearest 10,000th. 21 is similar. There's just a little bit more going on. So in the previous question, the base was already isolated, but in 21, that base is not isolated. It's being multiplied by -7. So recall that one of the first things that we wanted to do was to isolate the base. So here we want to divide by -7. So those -7s are going to cancel. And then rewriting, we get 3 to the negative a power equals 79 over 7. And then I'm going to take the natural log of both sides. Remember, that's one way that we could get the variable and the exponent down. So using our properties of logs, we can rewrite the exponent as multiplication in front of the log. So I get -a times ln of 3 equals ln of 79/7. So we still want to isolate the a. Right now it is being multiplied by the natural log of 3, so I'm going to go ahead and divide by the natural log of 3 on both sides. That's going to cancel. I get -a equals ln of 79/7, also divided by ln of 3. And then I want to multiply both sides of the equation by -1, or divide by -1, same thing, really. So putting all that into the calculator, I get -2.20 and then 5999, so that's going to round to 60. So always remember to plug in your answer just to double check it and make sure that it does in fact make the equation true. On this next problem, it's also another exponential equation that we're trying to solve. We do need to isolate the base. There's a couple things that are different. There's two things that are happening to the base before I can isolate it. And then in addition to that, our base is the number e. So that is also different. So first thing I'm going to do is get rid of that plus 3. And rewriting our equation, we get negative 6e to the negative 2b equals negative 46. And then I also see that that negative 6 is multiplying our base e, so we want to divide by negative 6. That's going to give us base e raised to the negative 2b power is equal to positive 23 over 3. So I just reduced that fraction because they're both even numbers, so I took out a factor of 2. Then I want to take the natural log of both sides, that way I can get my exponent down. So I'm going to use my power property to rewrite that. So I really have negative 2b times natural log of e equals natural log of 23 over 3. Now just remember that natural log of e is just 1, since they have the same base. And then I'm going to rewrite this here. I've got negative 2b equals ln of 23 thirds. So the only other thing that's happening to our variable is that it's being multiplied by negative 2. So the inverse operation is divide by 2, and we can get our b. So plugging everything into the calculator, we get negative 1.0184 for final answer. And just like always, remember to plug it in just to make sure that that is not an extraneous solution and that it does make the equation true. Really, those tend to pop up when we have quadratics, but it's a good idea to get in the habit of doing that.